Very good. We start recording as well. Good. All right. Bismillah ar-Rahman ar-Rahim. Alhamdulillah. Salatu wassalam ala Rasulillah. Yes. The last thing I talked about was limiting reactant. You remember the word limiting? The meaning of limiting reactant.
When will the chemical reaction stop?
What's the meaning of limiting reactant? Limiting reactant. If you have X and Y, to give you something, all right, which one is the limiting reactant, X or Y?
We have to check first.
Yeah, the one that will finish what?
First.
The one that will finish first is the limiting reactant. Limiting reactant. All right, clear? All right, good. Let's then move to limiting reactant, and we'll go, we already saw this. Let's go to now something else. Now, I want you also to know the word theoretical yield. Theoretical yield. What does that mean? Theoretical yield, what does it mean? Theoretical means by theory or yield. What's the meaning of yield?
المردود.
The outcome.
What? What's the meaning of yield?
The outcome.
Yield. In Arabic, the best thing.
المردود.
المردود ولا الناتج؟ المردود؟ والله ما أعتقد الناتج. I think the better word is الناتج. How much will be produced? That's the meaning of yield. How much will be produced? All right. And when we say theoretical yield, what does theoretical yield means? It is a yield by calculation. By calculation. This means, let's assume that I have H2 plus O2 to give you H2O. What's the first thing you must do?
Balance the equation.
And I will do it this way and this way. All right. Let's assume that I have one mole of this one and 1 mole of this one. Then which one is the limiting reactant?
H2.
H2 is the limiting reactant. Why? Because 1 mole of H2 will react with what? With how much of oxygen?
2.
Half.
2 oxygen.
No.
Half, doctor.
Just 1 oxygen.
1 mole will react with only half mole of oxygen, and the other half mole will be extra. Is this clear? Okay, good. Now, how many moles of oxygen of water we're going to produce?
1.
Half.
I need an answer.
1.
1
1.
mole will be produced. 1 mole, because 1 mole react with half mole to give you 1 mole. You always compare these numbers. All right. So if it is 1 mole with mole, we can say 2 mole will react with 1 mole to give you 2 mole. But I have 1 mole It will not react with 1 mole. It will react only half mole to give you 1 mole. This is clear. This 1 mole is called theoretical yield. Theoretical yield. Why we call it theoretical? Because it is by what?
Calculations.
By calculation. Let's assume that when you did this experiment at the lab, some water evaporated, it's not available, and you actually produced 0.7 mole of H2O. That's what you produced. What is this called? Now, this is called experimental yield. What is it called? Experimental yield. There is another name for it also. What is it called? Actual yield. How can you get the actual yield or the experimental yield? You can only get it by experiment. All right? And when I ask you, I repeat one more time. If we have 1 mole of H2 and 1 mole of O2, how many moles of water are we going to produce? Everybody says what?
1.
1. 1 mole, because by theory. Now, what will be the actual yield? Is it going to be 0.7 or 0.8 or point what? I don't know. It depends on what?
Experiment.
The experiment.
The experiment, depends on the person who's doing it, depends on so many things. And that's why the actual yield is not exact, or it's different from one person to the other. This is called actual yield or experimental yield.
Doctor, I have a question.
Yes,
Why did we say 2H2O, 2H2 has 1 mole and there is a 2 behind the hydrogen?
because look at the reaction. I already put, it's 2H2 plus 1 O2 to give you 2H2O. 2 mole will need only half mole to make 2 mole. 1 mole, sorry.
Yeah, and how do we know that the product will be 1 mole?
By the equation.
So we take the highest.
No. I'll do this in a while. Okay, wait a minute. All right, good. One more time. What's the percent yield? Percent yield is equal to actual over theoretical times 100. This is called percent yield. Is this clear?
Doctor, you mean here the mass or what? Actual over the theoretical?
And mass or mole. Actually, what would be the unit for percent yield?
No unit.
No unit. If it's mass, then it will be gram with gram, and gram will go with gram. If it's mole, then it will be mole with mole, and there will be no unit as well. Clear? So what's the percent yield for this experiment that we just did?
70%.
70%, exactly. 0.7 divided by 1 times 100, and it will be 70%. Okay, good. Let's do one more time. So this is called actual yield, and this is called percent yield. You have to memorize the names, and don't forget percent yield has no unit. Okay, good. Let's do one more experiment. Let's say that N2 plus 3H2 to give you 2 NH3. Okay? And if I tell you here, I have, I mean, I can put grams, but at this time I will put also mole. If I have, let's say that I have 2 mole of this one. All right. And I have 4 mole of H2. Okay. Then my first question, which one is the limiting reactant if I react 2 mole nitrogen with 4 mole of hydrogen?
2 mole nitrogen is limiting.
Hydrogen.
Hydrogen.
Hydrogen is the limiting reactant. Why? Because 2 moles need how much of hydrogen?
6.
6. And if I have 4 mole of hydrogen, then how many nitrogen? How many moles nitrogen do I need?
4 over 3.
4 over 3 exactly, which is 1 1/3. How much will be excess?
A third, 2/3.
What? 2/3 is excess. What does excess means?
الفائض.
Remaining.
Exactly. All right. This is what will be used only. Good. Now, how many moles of NH3 I'm going to produce?
Four.
What's the answer?
4.
4 more.
Wrong.
8 over 3. 8 over 3.
Yes. Yes, 8 over 3 mole NH3 will be produced. Is this clear?
Can you repeat it, Doctor, please?
I repeat one more time. When you have a chemical reaction, like this chemical reaction, then you can relate things by mole. In this chemical reaction, I can say from whenever I look, only look, I will say that 1 mole of this one should react with 3 mole of this one to give 2 mole of NH3. So 1 mole nitrogen from, this is from equation, When you have equation, then you can say that 1 mole of N2 should react with 3 mole of H2 to give you 2 mole NH3. Clear? That is from equation. Now, in the lab, I gave you 2 mole of this one and 4 mole of H2, and I want to know now, I mix that 2 mole with 4 mole. Now, I know that 1 mole needs 3 mole. If I have 4 mole of NH2, mole for H2, then what do I need from nitrogen? I need 1/3 of it, which is 4 over 3. Why? Because from the equation I know 3 needs 1, 4 needs 4 over 3. 1/3. Is this clear?
By cross multiplication.
By cross multiplication, exactly. The best thing is to say by cross multiplication. All right, next. If I use, this means 4 will react with only 4 over 3 of N2. How much will be left? I have here 6 over 2 altogether, or 2, which is 6 over 3. 6 over 3 is 2. Since I use 4 over 3, 2 over 3 will be excess, which will not be used in the reaction. And that's why we call hydrogen in this case limiting reactant. Clear? Now I go back. I need 1 mole to produce 2 mole of this one, to react with 3 mole to produce 2 mole of this one. If I have only 4/3, not 1, but I have 4/3, how many moles NH3 I'm going to produce?
8/3.
8/3. 8/3. Again, by cross multiplication. You can multiply this by 2 and divide by 1. This will give you this number, which is 8/3 mole NH3. Is this clear? Is this clear?
Doctor, how did we get 8/3?
Cross multiplication. Multiply 4 times 2 divided by 3. 4 times 2 divided by 3. What are you going to get?
Yes, 8/3.
Are you following now?
Yes.
What do we call the 8/3 mole NH3?
A theoretical yield.
Theoretical.
Theoretical yield. All right. Okay, good. Now let's assume that the percent yield was 70%, or let's have something 75%. Then what will be the actual yield?
25%.
What?
25%.
No, percent yield is 75. We are talking about the same experiment. This is the theoretical yield, and I'm assuming that the percent yield is 75%. What's the actual yield?
20%.
Theoretical yield. We can't get it from experiment.
You have to calculate it. What should I write at the top?
Put the equation top unknown.
X. Something we do not know.
We don't know what's x. And then at the bottom,
8/3.
8/3.
8/3 mole. Now, can you calculate x?
Yes, cross multiply.
1.87.
Do it in your calculator.
1.87.
1.87 mole. What's that? What's x? What's x?
NH3.
Actual yield.
It's the actual yield. It's the actual. Is this clear?
Doctor, isn't the answer 2?
No.
Yes, doctor, I get 2.
Yeah, the answer is
Yes,
2.
we got it.
You have to multiply by 100.
Yeah.
Ah, of
Two,
course.
doctor.
Oh, okay. Just I did not do it. I depend on your. Okay. Oh, it is exactly. Wow. So somebody gave me a wrong answer because I did not do it, the calculation. Now I did the calculation. So the actual yield in this case is 2.0. Is this clear?
Doctor,
Yes.
Doctor, how did you know that the yield is 75%?
I'm telling you. I said if the experiment was 75% yield, what was the actual yield?
Oh, okay.
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 Good. All right. Let's solve this problem. I have aspirin. Okay. This is called aspirin. Do you know what's aspirin?
Painkiller.
To make the blood motor.
Most famous painkiller, which is called aspirin. This is aspirin. Okay, it is produced by salicylic acid. You don't have to know these things, and acetic anhydride to make salicylic acid. Aspirin and acetic acid. You have this reaction. Look at the reaction, and this reaction is already balanced. Is it? Yes, it is balanced. All right. Can you check if it's balanced? Very quickly, you should check. Tell me, is the number of carbon on both sides the same?
Yes, Mr.
Yes,
It's balanced.
balanced.
About hydrogen? Hydrogen, is it the same?
Yeah, all elements.
All, okay, how about oxygen? Also balanced, good. So, what do you understand from this equation? That 1 mole of this one react with 1 mole of this one to give you 1 mole of this one and 1 mole of this one. This is by the equation. I did not even read the question. Okay. Now, I went to the lab and mixed 104.8 gram of salicylic acid. So I have here 104.8 gram of this one. I mix it with 110.9 gram of acetic anhydride. Okay. I want to know if I produced, see, what's the meaning of produced?
Product.
You make it.
And
You made it. So what is given to you here, is this the theoretical yield or the actual yield?
Actual.
Actual, why are we saying actual?
Because it's produced.
Because that's what you
already
in
produced.
the lab. So this is the actual yield. So what's given to you here is the actual yield. We want to know what's the percent yield. Can you calculate the percent yield?
Yes.
What's the first thing you must do?
Change to mole.
Convert grams to moles.
Never deal with grams, deal with moles. Okay, what's the very first thing you should do to calculate the mole?
The molar mass.
The
Molar
Divide by molar mass.
You know, everybody knows that carbon is 12.01. Hydrogen is what?
1.0.
1.008.
And oxygen?
16.
16.00. Look at your periodic table. Okay, tell me what's the mass of salicylic acid, the first one. I will write the mass up for each one.
8.12.
What is again?
138.12.
0.12. Fantastic. Yes, gram per mole. Per mole. Okay, how about acetic anhydride? Who got it?
102.08. 09.
09. Okay, how about aspirin or acetyl salicylic acid? 180.
8 gram.
What again?
115.
Gram per mole. Very good. What's the next step?
Determine the limiting reactant.
Determine the number of moles. So moles here. Tell me what is the mole. What's the mole for salicylic acid?
divide.
0.758. 8 gram.
Have numbers. Make sure that you know you should divide 104.8 divide by 138.12. What's the answer? Zero
0.76.
7. Give me third number. 7, 6, what?
No, it's 0.
767.
758.
758 mole. I'll take this. Good. How about for acetic anhydride?
1.086.
1.08.
086.
1.08. 0.6, you mean? No, 6. Good. Yes, good. Mole. Good. Next. My next question. Which one is the limiting reactant?
Salicylic acid.
Salicylic acid. Why? Because it's less and it's 1-to-1, right? 1-to-1. That's why 0.758 needs how much of acetic anhydride of this one?
0.7.
0.758.
What will be the excess then?
The difference between them.
Excellent. Now, tell me how many aspirin or acetyl salicylic acid will be produced?
0.758.
0.7875.
0.758 mole of this one will be produced. Good. And this is now called what? Theoretical or actual yield?
Theoretical yield.
Theoretical yield. Theoretical yield. Don't forget this. Can you change this into gram?
Yes.
Okay, give me what will be the mass in gram.
141.4.
Multiply with 180.
Exactly. 0.758 multiplied by 180.15. What's the answer?
141.42.
142?
No, 141.
Looks too much.
136.5.
136.5537.
136.
0.5537.
0.56. 136.56. Who got the same answer?
0.55.
5537.
55. I don't mind. Let's stop at 55. 136.55. That's, you just multiply 0.758 times 180.15. You should get, everybody got 136.55?
Yes, sir.
Good.
Yes.
Then what's the percent yield? What should they do?
Put the
You should divide.
over the
Over
136.55.
136.55
Multiplied by 100.
multiplied by 100.
77.33%.
77.33%.
Yes.
What's the unit?
Nothing.
No
unit.
unit.
No unit.
No unit. Is this clear? How easy?
Doctor,
Easy.
Yes.
what's the theoretical?
By
In,
calculation. That's exactly the right answer, which is good.
The theoretical is the
Is this amount, which is by calculation.
it's
Theoretical.
all in the gram.
What?
I said it's always in gram, the theoretical.
No. The theoretical,
Oh,
you mean?
it's all the gram and the mole are theoretical, right?
Yeah. Well, whatever you do by the equation, we did this by equation. We did not look at the experiment. By calculation, when you do the calculation in the equation, like I'm reacting here one with this one to give you this one. I have this amount with this amount, so it gave me 136.55 of acetylic acid, which is aspirin. This is by calculation. The one which is the number 136.55, I got it by calculation from the equation. This is called now theoretical yield.
Oh, okay. And the actual, he always give it to me.
Yes. No, I can give it to you, or I can give you a percentage and ask you to find the actual. Everything is possible.
Okay, yes.
Okay.
Doctor, doctor, can you go back? 180.15. Do we get it from 1 mole of acetic acid?
This is the mass. Go to the periodic table and find what's the mass of C9H8O4.
Yeah, but why didn't we calculate both moles masses? Why just one?
By the equation, I'm looking what's the mass per mole. That's for 1 mole. This is per mole. This means for 1 mole only.
Yeah, then why did we C2H3O2? Why did we not calculate this one?
ما طلبها في السؤال.
Okay.
You don't need it. You can do it, no problem.
Okay.
But you need it in the question. Exactly.
Thank you.
Okay. Good. Very good. Now, very simple words. I want you just to know the meaning of what do we call this type of reaction? We call it combination. You're combining this one with this one to make a product, to make one product out of 2. What do we call it? Memorize the name.
Combination.
Ammonium chloride.
No. Memorize the name, which is this one. Combination reaction. Why? We're combining X plus Y to make XY. What type of reaction is this one?
Combination.
Combination reaction. What do you call this reaction?
Decomposition.
Decomposition reaction. We take X and Y and make X plus Y. What do you call this reaction?
Decomposition.
And the last one,
التفكك بالعربي.
yeah, the last thing, whenever you have organic compound with oxygen, what are you going to get?
Combustion.
Composition. Carbon dioxide and water.
Dioxide and water. This reaction is called what?
Combustion.
What's the other name? You can use other name for it. Burning. Exactly. Burning or combustion. You have to memorize these three names. Good. Okay, the first question. What type of reaction is this one?
Combination.
Combination. First one is combination. Second one.
Burning.
Combustion.
Combustion.
Combustion. And third one.
Decomposition.
Decomposition. Is this clear?
Doctor,
Yes.
if we always have O2 in the, not the product, the before the product, it will always be the composition or the burning.
Combustion, not composition.
Yes,
Combustion. Yes.
Okay.
Not only with organic compound. This has to be organic. What does organic mean?
Included the C. Included the car.
Contain carbon, hydrogen, and other things like oxygen or nitrogen. But the main thing is carbon and hydrogen. Clear? Okay.
Yes, doctor.
With this, we finish chapter 3 completely. And right away, I will start with chapter 4. Just 1 second. Okay, and what's the title chapter? Oh, it's 5 again. Okay. All right. Chapter 4. What's the title?
Reactions in aqueous solutions.
in aqueous.
What are you going to do in this chapter? We're going to do reaction in where?
Water.
Aqueous solution.
Aqueous.
Water.
Means what? What aqueous means?
Dissolved in water.
Dissolved in water. Aqueous, it is in water, whether it is dissolved or not. But reaction in water solution. I can say this easily. I can say reaction in aqueous solution, or I can say reaction in water. Reactions in water. Good? Good. Before we do any work, I will give you 3 words you must memorize very well. Solute plus solvent to give you solution. All right, I want you to memorize this word. What is the solvent? In this chapter and in other chapter, it will be the thing that you dissolve thing in it is called, in this case, it is water in this chapter. The thing that you dissolve thing in it, it's called solvent. What's the meaning of solute?
Something that dissolves.
The thing that you dissolve. And what are you going to make?
The solution.
Solution. So solute plus solvent give you solution. Give me example of solutes.
NaCl, NHO.
What else?
Tea. Shai.
Anything, or give me compounds. Shai, we don't know what's the structure, but let's say that I have even ammonia, for example, NH3. I can dissolve, all of these can dissolve as solute. And what's the solvent? In this chapter, we're going to deal mainly with water because it's the title. Can we have something else other than water?
Yes.
Yes, you can.
Like what?
Any other liquids?
Yeah, like for example, alcohol, CH3, C, H2OH. This is other alcohol. They use it in, it could be a good solvent, or other solvent like benzene, C6H6. We can dissolve things in benzene or anything. If it's liquid, we can put things in it and dissolve in it. Is this clear? Good. Okay. So generally, what do I want you to memorize? The 3 words. What are the 3 words? What is it?
Solution, solvent, solute.
Oh, this one. What the first one?
Solute. Solute.
Pronounce it and memorize it. Solute. What's this?
Solvent. Solvent.
Solvent. What is the total thing?
Solution.
Solution. Good. Right. Next, I wanted to know electrolyte and non-electrolyte. 2 words. What does electrolyte means? Conduct electricity. This means, what's the meaning of non-electrolyte?
Does not conduct electricity.
Exactly. What does the conduct electricity means?
موصل
transfers electricity.
This means conduct electricity if I put electrodes, if I have solution like this and put 2 electrodes like this one and connect this to electricity or to lamp like this one, this experiment here, then the electricity will go through or will not go through. See, I put 2 electrodes here in this lamp, and in here the electricity went through and it's strong. Can you see it? Here the electricity did not go through, but here it is weak. Can you see the light here is very strong and this one is weak and this one none, no electricity. Okay, what does that mean? Is this solution electrolyte? This solution, is it electrolyte or not electrolyte?
It is electrolyte.
It must be strong electrolyte. Clear? How about this solution?
Yes.
Weak electrolyte.
It is also electrolyte, but
It's weak.
Electrolyte. Okay, how about this one, the last one?
Non-electrolyte.
Non-electrolyte.
Non-electrolyte. Is this clear? Good. What makes things electrolyte or non-electrolyte? All right. If you have ions in solution, then it will be electrolyte because these can conduct electricity. If there is no ions in solution, then this will be non-electrolyte. If you put sugar in water, is this going to be electrolyte or non-electrolyte?
Non-electrolyte.
Non-electrolyte.
Non-electrolyte. Okay, how about NaCl in water?
Electrolyte.
Electrolyte.
Good? Clear?
Doctor,
Yes.
again, how do we know?
If you have ions, do you have ions in the first solution? In sugar, do you have ions in the product?
No,
Is this electrolyte or non-electrolyte?
non-electrolyte.
Okay, how about NaCl? Do you have ions?
It is. We have ions. Okay.
You have ions, and it will not dissolve in water. I mean,
We have to have it in the product, doctor?
again?
Do we have to have it in the product only?
Yeah, because it will not be happening except in the water and the product. Otherwise, it's not a compound. Okay? How about if I dissolve C6H6 in water?
Non-electrolyte.
Non-electrolyte.
Aqueous. It was here liquid. Now it is aqueous. Is this electrolyte or non-electrolyte?
None.
It is none.
None.
None. How about if I dissolve potassium bromide in water?
Electrolyte.
Solid. It will give you K plus aqueous plus Br minus aqueous. And this will be electrolyte. So this one is electrolyte. This one is none. Is this clear? Good. We usually, when we have ionic compound like NaCl, we use the word dissociation to make Na plus Cl minus. But if you use also ionization, it's okay. So if you use ionization, it is acceptable. But usually, if you talk to scientists, they will say always use the word dissociation. Why we call it dissociation? Because it is dissociation reaction. You remember dissociation reaction? Chapter 3.
Is it the same decomposition?
Decomposition or dissociation. This is actually not decomposition. It is dissociation because it is dissociate. I mean, it is separated only. Dissociation means separated, like this. Okay.
Doctor, does it happen to every organic compound?
Well, yes, to a great extent. It should happen, but not in water. Something in water. We'll talk about this in a while. Okay. If you have, this is called ionic compound. So for ionic compound, what's the word we use when we make ions?
Ionization.
No.
Dissociation.
Dissociation. We rarely use ionization. It's okay if you use ionization, but you should say dissociation is better. But if you say ionization, it's acceptable. But if you have non-ionic, molecular compound. What's molecular compound means?
Consists of non-metals.
With non-metal, exactly. Non-metal with non-metal. If you have ionization, some of the compounds like HCl dissolve in water, it was gas, and become H plus Cl minus. This process, we call it ionization for molecular compounds. For ionic compounds, we say dissociation. Is this clear? Now, HCl, does it conduct electrolyte or non-electrolyte?
Electrolyte?
Yes, why?
Because there's ion.
Forms ion.
It forms ions. So yes, it is electrolyte. Good. Now, also, when we have things like produce OH minus, anything produce H plus is called what?
Acid.
Ammonia.
Acid. Anything produce OH minus is called what?
Base.
Alkene.
Base. Okay. Anything produce H plus is called acid. We took this in chapter 2. OH minus, we did not talk about it, but anything produce OH minus is called base. That's why NH3 react with water to make NH4 plus OH minus. NH3, is it acid or base?
Base.
Base. Why?
Produce OH minus.
Produce OH minus. NH3, which is a base, is it electrolyte or non-electrolyte?
None. It's non-electrolyte.
What?
Non-electrolyte.
Why?
Because
Wrong.
there is no ion.
No, it's wrong. It's electrolyte. Tell me why it's electrolyte.
Because H is positive and N is -3.
Because ions.
Because it produces ions. NH3 by itself, it's not. But if you dissolve it in water, it becomes electrolyte. NH3 by itself is non-electrolyte.
Doctor,
Yes.
ions should be in the result, so we could say it's electrolytes.
Yes.
Okay.
Okay. All right.
You say NH is non-electrolyte, Doctor?
NaCl solid. Is this electrolyte or non-electrolyte?
Electrolyte.
Non-electrolyte. Why?
Because it's
Because
on its own.
itself.
It's solid, and There is no ions. Now, when you put it in water, what is going to give you?
Na plus Cl
ions and
minus.
chloride ion.
This electrolyte or non-electrolyte?
Yes.
Same thing. Is this electrolyte NaClCO solid? Is it electrolyte or non-electrolyte?
None.
None. How about 3 by itself?
None electrolyte.
What? When you dissolve it in water?
Electrolyte.
It becomes electrolyte. I hope this is clear. Good. We have what's called strong electrolyte and we have weak electrolyte. Before I go to strong electrolyte and weak electrolyte, I want to produce one thing. If I put an arrow like this and I say X plus Y goes to X plus Y, that's just so many things. All right. I say this one is complete reaction. Okay, but if I write or give me A, B goes to A plus B minus, and I put 2 arrows here. What does 2 arrows mean? Means A B can go to A plus and B minus, but what will happen? A plus and B minus
opposite side
can go to the other side. And so this is, we call weak reaction. Weak. I should not say, I will not use weak, it's wrong. I will say incomplete, not complete, or
Equilibrium, doctor.
yes, it is in equilibrium actually. And non-complete. So it's not complete. Now, when you have electrolyte like NaCl goes to Na plus Cl minus, this will be strong electrolyte. Why? Because it's complete and it will decompose 100%. But if you put the other things, all right, like for example, if I put HF in water, what will happen? It will give you H plus F minus, but only about 10% of this one will decompose, only 10%, and 90% will stay as, this means, let me write this here, instead of this one, I will put HF goes to H plus aqueous plus F minus aqueous. 90% will stay like this, and 10% will stay like this. So, is this going to be strong electrolyte or weak electrolyte?
Weak.
Very weak.
Weak.
Because only small amount will be produced. While if you have an NaCl, like this one,
50.
After you put it in water, how much of NaCl will be left?
0.
Nothing.
0%. How about Na plus and Cl minus?
100.
100% will be decomposed like this. And this is why this will be called what?
Complete.
Strong.
Strong electrolyte. While HF will be called what?
Weak.
Weak electrolyte. Good. Next. What are the strong electrolytes? or I want you to memorize these acids. Sit down today in the table and memorize the name of these acids. Hydrochloric acid, hydrobromic acid, hydroiodic acid, nitric acid, chloric acid, perchloric acid, sulfuric acid. All these, how many now? 1, 2, 3, 4, 5, 6, 7. 7 acids. When they dissolve in water, they dissolve completely. And they are what? Strong electrolyte. You have to sit down and memorize them. All right. Now, let me ask you very quickly. HBr is a strong electrolyte or weak electrolyte?
Strong.
Yes. Strong.
Strong electrolyte. Okay. How about HClO3?
Yes.
What's the name?
Yeah, strong.
Strong.
Chloric acid.
Chloric
Right.
acid. You have to memorize this. Now, let me ask you, HF. Is it strong electrolyte or weak electrolyte?
Very weak.
Weak electrolyte. Weak electrolyte. All right. Okay. How about if I have HClO2?
Strong.
Weak.
Weak. Weak electrolyte. What's the name of this acid?
Chlorus.
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 Exactly.
Chlorus.
Chlorus acid. You have to memorize it, chapter 2. Good. So these are the only 7 acids which are completely, and they're strong, and you have to memorize them. And they decompose completely. That's why I draw strong acid. Now, whatever is produced from H2SO4 is called hydrogen sulfate. Hydrogen sulfate, is it strong acid or weak acid?
Strong.
Weak acid.
Weak.
Why did you say weak?
Because it's incomplete.
Because
Not all of
there
it,
is
just
2
a
arrows.
There's 2 arrows.
2 arrows, exactly. Look at the 2 arrows. I put the 2 arrows to tell you it's 2. Now, let me ask you about a very famous acid. What's this acid?
Acetic acid.
Alcohol.
Acetate.
Acetic acid.
الخل.
Vinegar.
Is this strong or weak acid?
Weak.
Weak.
Weak acid. Weak acid. Good. Did you memorize them?
Doctor, not yet. Doctor,
Yes.
how can we use them after we memorize them? Like, why do we even memorize them? What's the benefit in the exam?
I want you to tell me if they are strong or weak, and I want you to write this equation. If I tell you HCl, first question, is it strong electrolyte or weak electrolyte?
Strong.
Very good. Well, how did you know that's strong? Because you
Because
memorized,
it's-
right? Good.
Yes.
Next, how, when it says strong electrolyte, I want you to write a reaction for the strong electrolyte. How are you going to write it?
Plus and minus.
H plus
Ions.
plus Cl minus, and yes, you have to write aqueous, and here gas. Good. Now, how many arrows should I write?
1.
Why not going back like
Because
this?
it's strong.
Because it's strong. If I write it this way, your answer is wrong. Clear?
Yes, yes.
Doctor,
What I want to know.
any acids except those 7 are weak.
Exactly. Any acid other than these 7 is weak, including this one, including HF, including chlorous acid, including anything else.
Doctor,
Yes.
HCl, isn't it should be aqueous?
HCl?
Yes.
No, HCl is gas. If it's by itself.
Because in the table, why they wrote aqueous?
Right, aqueous because it's in water now.
Okay.
Yeah. If it's by itself, then it will be gas. If you bubble the gas in the liquid, it will be HCl aqueous, but it will not stay like this. Right away, it will become like this. 0% of this one will be left.
Doctor,
Yes.
the HSO4, the last one, is weak.
Yes.
Why they put in the strong acids? Because it's famous or what?
No, because it comes from the strong acid.
Oh, okay.
Okay. Now, what's this acid called?
Acetic acid.
Acetic acid. Acetic acid. Why do we call it acid?
Because there's an extra H. Reduce it.
Why do we call it acid?
It
Produce
produces H ion.
hydronium.
Plus. Produce H plus. Clear? Good. Next. Ammonia. Ammonia, when it dissolves in water, it will give you NH3 plus H2 to give you NH4 plus OH minus. Is this acid or base?
Base.
Base. Base. Is it strong as a strong base or weak base?
Strong base.
Weak base.
Weak base.
Weak.
Why weak?
Of the two arrows.
See, look at the two arrows. All right. This means only less than 10% will decompose of this one. Less than 10%. Less than 10%. Most of it will be more than 90% will be left as NH3 in water.
And Doctor?
Yes.
Are all weak acids less than 10%?
Yes, most of them. Very, very rare you have more than 10%.
Doctor?
Yes.
In this case, we'll say weak acid or weak base.
What do you say? Weak acid or weak base?
Weak base?
Of course. Why you say acid? It's not acid. It's base. So you say weak base. Weak base. Is it weak electrolyte or strong electrolyte?
Weak.
Weak electrolyte. Don't forget this also. Now, we finished with the acids. Let's talk about no. So, very good. Let's continue from here. Good. So, from now on, when I give you any compound, you know what we call this strong electrolyte, this is weak electrolyte, and this is non-electrolyte. Why we call it non-electrolyte?
It doesn't create any ions.
Yeah, but doesn't conduct what?
It doesn't conduct electricity.
Good. Now, how do I know if it is going to be strong or weak or whatever? The first question is, ask yourself, look at this table and listen to me when I say things. Is the compound ionic or molecular? What's the difference between ionic and molecular? What's ionic?
Metal plus non-metal.
Non-metal with metal.
With non-metal. Very good. What is molecular?
Non-metal with non-metal.
Non-metals.
With none. Good. Not molecular. Then ask yourself, is it ionic or molecular? If it's ionic and dissolve in water, then it will be what?
Strong electrolyte.
Strong.
Yes.
You don't have to think. Like an ACL, is it strong electrolyte or weak electrolyte?
Strong.
Okay. Then if it is molecular, then ask yourself, is it acid or base? Molecular, non-metal with non-metal. Don't talk about other bases like NaOH. Is this considered to be NaOH? This is base. Is it ionic or molecular compound?
Ionic.
Ionic. So we are not going to put it here. So good. If it's molecular, ask yourself, is it acid or base or neither? Okay. If it's acid, then it will be always weak electrolyte. Give me example of molecular acid.
Acetic acid.
Acetic acid, CH3COOH, and it will be what? Weak electrolyte. Okay? Okay. If it is, I said this is base, but I should put the acid here. Okay. CH3COOH, I should put it here. Erase this. Sorry. Yeah, as I said here, ask yourself, is it acid or base or neither? If it is base from, not like NaOH, because NaOH is ionic, but give me a base which is molecular.
NH3.
NH3, exactly, which we just talked about a while ago. Is this going to be strong or weak electrolyte?
Weak.
Weak electrolyte. If it's neither, then it will be
None.
non-electrolyte.
Doctor?
Yes.
How can I differentiate between neither and base when I have a molecular?
I'll tell you in a while. I'll tell you. Good question. Neither, if anything, does not contain either the COOH group. What's this group called? You remember this group?
Carboxyl.
Carboxylic acid. Carboxylic acid. We took it in chapter 2. I told you I want you to memorize the name of this group. COOH is called carboxylic acid. Anything that contains carboxylic acid, it will be acid and it will be weak acid. Anything that contains nitrogen, NH3, or let's say NH3 NH3 NH2. What is this called? What's this group called in chapter 2?
Methylamine.
No. Amine, yeah. The group is called amine. Yes, it's methylamine, exactly. Methylamine are all weak bases. Or anything contain amine is weak bases. Anything that contain COOH is what? Weak acid. All right, and give me example of non-electrolyte. It's neither acid or base. Give me example.
H2O.
No, H2O is not. Yeah, H2O is good. Well, that's. I was thinking organic. H2O is acceptable. But what else? Because we're dealing with H2O, we don't want H2O. Let's say C6H6. Is this acid or base or what?
Neither.
Okay, let's solve this example then. Very good. Based on this table, tell me methanol, CH3OH. Is this going to be electrolyte?
Electrolyte.
Strong or none?
Weak electrolyte.
No, wrong.
Isn't it base?
No, that's why I say the base contain what?
OH minus.
Organic compounds. Which base? What is the base? It must contain what?
Ammonia.
Amine. Ammonia for by itself, but when it's with carbon compound, it's called amine. It must contain amine to make base. If it's OH, like CH3, OH does not conduct electricity. It's neither. Clear?
Yeah, okay, yeah.
Okay. How about the second one? Is it weak, strong, or none?
Neither.
Strong.
None.
Strong. Ionic.
Strong. Why? Because ionic. Okay, how about third one?
Weak.
What weak?
Chemical base.
Base.
Contain amine, that's why it is weak, exactly. How about HF?
Weak.
Weak.
acid.
Weak. Why?
Not
It's
one of the
not,
seven.
Because it's ionic.
Exactly.
bound.
Molecular, but not among the seven strong one. How about HI?
Strong.
Strong acid. Okay, I want you to memorize this, all of these things. All right? Good. Let's move. Now, when you put NaCl in water, you will find that right away NaCl will go to Na plus Cl minus in water. Aqueous. But if you put calcium carbonate, this is called calcium carbonate. All right? This is an ionic compound, right? Because it's metal with non-metal, or with non-metal group. But if you put this in water, it will not dissolve in water. It will precipitate as COCO3 solid. It will stay as it is. It will not make ions. All right? We call this, we call it ionized. But the second one we say precipitate. ترسب. Precipitate. ترسب. Okay? But we call this ionized. معناتها make ions. Okay? Or we call it dissolve. To make dissociation. What does dissolve means?
ذائب.
تذوب.
Disappear in the water.
Good. Is this clear? Now, some ions will dissolve, and I'll stop here. I will stop here and we'll continue discussion, inshallah, on Wednesday. Okay, before I completely stop, let's stop here. And then, okay, now the sitting is open. Please take attendance, and when you take attendance, you can leave right away. Okay.
دكتور
يعطيك العافيه دكتور.
يا هلا مع السلامه، ان شاء الله نشوفكم الاربعاء.
Doctor, you talked about